Okay, gang, so now we're gonna move to the concavity. So if I'm between 0 and 104 degrees, by the way, it's it seems like 105, 4.5 is more accurate. I seem to have changed the number along the way, but I'm still pretty close, so I'm not gonna go back and change all the videos, but it does look like I should have rounded it to 104.5. I did that at one point, but for some reason I changed it. But it's pretty minor. It's not really going to change my answer, so I'll keep it. But just so you know, if you want to be like round that better than I did. Okay, so between 0 and 104 degrees would be pi over 2. That's 90, right? So that's a good one to pick in the middle there. In terms of, let's see, if you're between 1.8 and pi is about 3.14 radians. So I picked 3 because 3 falls in between 1.8 and 3.14. Over here, 4 falls in between these. And over here, 5 falls between these, because this is 2 times 3, which is about 6. All right, so those are the numbers I'm using. I'm going to plug it into the second derivative. And let's see how this goes. So sine of pi over 2 is 1. So this is negative 2 times cosine of pi over 2 is 0. So it's 4 times 0 or 1. Okay, so this is negative, this first value. All right, now this I have to use a calculator for the numbers I picked, and I have to make sure I'm in radians, not degrees. 3 degrees is way different than 3 radians, way different. All right, so I just want to know if it's positive or negative. So negative 2 times sine of 3, that is negative. Again, all I'm going to do is the signs. And then times 1 plus 4 cosine of 3. That is negative, so it's a negative times a negative, which is positive. So this guy is positive. All right, now I'm going to plug in a 4. And again, all you care about the sign. You could technically make it 3 different things, the negative times whatever this is. I'm just putting these all together. I guess I'm just trying to get through this question, but you could make it 3 parts if you want. All right, so negative 2 times sine of 4, that is positive, times 1 plus 4 times the cosine of 4, that is negative. So that's a positive times a negative, which is negative. You can sort of guess which way this is going, but I'll do it. Negative 2 times sine of 5 is positive. 1 plus 4 times cosine of 5 is positive. So positive times a positive is positive. So this is positive. Okay, 10 years later, we've got an answer. Sharpen that pencil. Okay. All right, so let's write down the concavity. All right, here we go. We earned this. We earned this moment. All right, here we go. Concave up. All right, where are we concave up? From the 1.823 to the pi. And from the 4.46 to the 2 pi. All right, and we're concave down from 0 to 1.823. And pi to 4.46. All right, so that's the answer to that part. Now let's do inflection. So would we say this is inflection point? Yes, right, because it goes from concave down to concave up. It's switching concavity, concave down to concave up. So this is an inflection point. How about here, pi? Would we say this is an inflection point? This is, right, because it goes from concave down. Sorry, that's positive. Concave up. It goes from concave up to concave down. So that's an inflection point. How about here? Is this an inflection point? It is, right? Because it's going from concave, this side's concave down to concave up. All right, so we have 3 inflection points. 1.823 pi and 4.46. All right, this is the like the flourish, the finale here of this marathon. Now, where do you plug this in to find the inflection points? Good, you plug it into the original. Do not plug it into the second derivative. I'm not asking you what is the second derivative equal to. I'm asking you where's the point on the graph. So you want to plug this into the original problem. Do we even remember what it is? It's this one all the way here, what we started with, right? This, let me just write it over here. It's see, f of x equals to 2 sine x plus sine 2x. So we want the xy value for all of these. All right, here we go. And yes, you need a calculator for this. All right, so the first one, and again, make sure you're in radians, else this won't come out right. So for the first one, you're going to do f of 1.823 equals to 2 sine. All right. You could also use a double angle formula here if you want before you plug in the number. It's just up to you. There's more than one way to do this. Okay. 2 times sine 1.823 close parenthesis plus sine. Now all of this is going in the sine, so I 2 times 1.823 close the sine. All right, that is going to be about, I'm just going to round to the 10th digit, 1.45. Okay, 1.45. Awesome. All right, the next one we can do in our head, because that's a pi. That's this one, we can do that. That's a quadrantal angle. You'd be thinking of the unit circle. Okay, remember you're on the unit circle. So sine of pi, that's over here. The sine is the second value, so it's 0. So that's 2 times 0, 2 times 0. Now 2 pi is over here, right? That's your second value. So plus 0. So this is overall 0. Right, because this is going to be 0 plus 0. All right. Woohoo! Almost there. Let me see if I can squeeze this last guy in here. F of 4.46. So 2 sine 4.46 plus sine times 2 of 4.46. All right, back to the calculator again. You gotta be in radians. Okay, so 2, no, that's a 4. 2 times sine 4.46 plus sine, oh, hold on a second. You gotta close that. 2 sine 2 times sine of 4.46, close it, plus sine 2 times 4.46, all inside the sine, close it. Okay, negative 1.45. Negative 1.45. Okay, gang. That's it. There you are. Those are the magical inflection points. I hope this helped. I have a feeling if you watched all whatever half an hour of this thing, it did. All right, I'll catch you. Bye-bye.